We want vertex form for quadratic functions, and in this case the vertex is read right out of the equation. You have to get it in this form to be able to do that. And so let's look at some of these notes as we go through. In this equation, the vertex is the point HK. Alright, now what it's going to look like is that they're changing the sign of H, but you're not, because if you think of it as X minus, and then your H is in here, that's a positive number if it just looks like X minus H, and so the H will be positive. If it looks like this, X plus H, then that's the same as X minus a negative H. And so if you have a plus in your parentheses with the X, your H is negative. So it kind of looks like you're changing the sign, but you're really not, but you have to remember that. The equation for the axis of symmetry, and remember this is always a line, it's always an x equals line because it's a vertical line, is x equals h. And let x equal 0 and solve for the y-intercept. So looking at this first equation, we still look at this coefficient here, this a, to see if it's going to be going up or down, opening up or down. So this one will open up because that's a positive number. Now our h, let's just read it. Let's just go ahead and do our vertex. Our h is 2 and our k is 5. So that's our vertex. And the axis of symmetry is x equals h. So that's x equals 2. For the y-intercept, you have to make x equals 0. So we have 3 times 0 minus 2 squared plus 5. Okay. And that's then 3 times negative 2 squared plus 5. So that's 4 times 3 is 12 plus 5 is 17. So the y-intercept is the point 0, 17. Okay. The domain of any quadratic is all real. Okay. And the range is going to be, let's look, let's graph this. We're going to go over here to 2 and up 5. And that's our vertex, okay, at 2, 5. Okay, and that 2 is hard to read, but that's what it is. And we go way up here to 0, 17. 0, 17 is our y-intercept. And we kind of just have to sketch it from there. Remember, our axis of symmetry is going to be symmetric about this, so 2 spaces away from the axis of symmetry over here, we have another point. And then we can kind of sketch in our quadratic equation. And I missed my vertex, but anyway, you would need to go down and hit the vertex with that curve, because that's the minimum. Okay. So that is your sketch of your quadratic. The range then is everything bigger than 5. So it's 5 to infinity, curved bracket on infinity, square bracket on the 5. Alright, looking at our next graph, we have a negative 2 in front. So our direction, it opens down. Okay. Our h, this time with x plus 4, our vertex, our h is negative 4, and our k is negative 6. Okay, so we go over here to 4, negative 6, somewhere down here, and that's negative 4, negative 6 is going to be our vertex. The y-intercept, we set the x equals 0, so we have negative 2 times 4 squared minus 6. That's 16 times 2, negative 32, minus 6 is negative 38. So at 0, negative 38, we have a y-intercept. So that's way down there. I can't even really get that on the graph, scale-wise probably. And then we're going to sketch our quadratic function. Okay? And you should label those points when you sketch it. Our axis of symmetry, it's x equal the x value of the vertex, so x equals -4. Domain in all quadratics is all real, or from -infinity to +infinity. And the range, remember you list the -infinity first, and it goes up to 6, and it includes 6. And this is -infinity to +infinity. All right. So that's our first couple examples of vertex form of quadratic equations. Let's move this down to the next page. Go over here and grab it. Go down to the next page. Now this is a little different approach. We have to write the equations where f of 1 equals -7. So that means we have a point -1, -7, and that's an x and that's a y. Okay? And we have a maximum value at f of 2 equals -1. So our maximum, which means that's our vertex, is at 2, -1, and it opens down. Okay, so that means we have to have a negative in front. If it's a maximum, remember it opens down. So we remember our formula. Y is equal to a, should be an a in front, parentheses, x minus h squared plus k. Well, we put h and k. That goes from here. That's going to be h, and that's going to be k. So we have y equals a times 2, minus 2 minus 1. Okay? And there should be a square there. Now we have to figure out what a is because we've got too many variables. So we use this x and y, and that'll leave only a that we don't know. So we have -7 is equal to a times -1 minus 2 squared minus 1. We're going to add our 1 across, so we have -6 equals, and this is going to be -3 squared, so that's going to be 9a. And so when I divide by 9, a is equal to -6/9, which is -2/3. So now we can write our formula, our vertex equation, y equals -2/3, and it is negative as it should be, x minus 2 squared minus 1. So you have to put it back in vertex form. Okay, that is the equation of a quadratic. Now we have a minimum. We have a minimum point. That means it opens up, and our minimum is our vertex. So our HK is 3, -5. And we have a point, an xy point, of 1, 2. Remember f of x, so x is what's in parentheses, and that's our y value. Same process then. We have y equals a times x minus 3, we use our h there, squared, minus 5. Then we have to put in our x and y, so we have 2 equals a times 1 minus 3 squared minus 5. We add 5 across, so we have 7 over here. And 3 minus 1 is 2. 2 squared is 4, so that's 4a. So a is equal to 7/4. And so our final formula, we really probably should put it in function notation, is f of x equals 7/4 times x minus 3 squared minus 5. Okay? And our last example, write the equation of a function in vertex form with zeros. So this have zeros. We know roots. We know root 1 is at -1, 0. And root 2 is at 3, 0. And we have a maximum, that's our vertex value, of 8. Okay, our max is equal to 8. So what do we know? We don't know the x value, that's a y value, so we know that we have x and we have an 8. That's our maximum point. Well, we can figure this out because we know these x values, and the vertex is always halfway between the roots. So that x can be figured by -1 plus 3 over 2, which is 2 over 2 or 1. So that can be, that's our x. Okay, so we know this is 1, 8. So now we know a vertex. Okay, so we have y is equal to a times x minus 1 squared plus 8. Okay, and we use one of our roots then for our xy point. Now, it doesn't matter, but I'm going to use 3, 0 because they're all positive. So 0 equals a times 3 minus 1 squared plus 8. So I'm going to add 8 across and have -8 is equal to 4a. That's 2 squared. And then when I divide by 4, I have -2 equals a. Okay. And so my final equation is f of x is equal to -2, and it should open down, so it should have a negative number here. And then we have x minus 1 squared plus, excuse me, let me think, plus 8. Yeah. Okay. Alright, and so that is our final answer for this one. Okay, that's it for lesson 4.